Okay, hello and welcome back. This is a calculus tutorial, and this section I want to work on is called trigonometric integrals. This is the first part of a few different parts. I'm not sure how many I'm going to get to. But if you're looking at an integral like this one, where you have a sine times a cosine, probably both raised to a power, you need to look at a couple things. Which one's raised to an even number? Is there one raised to an odd number? So you have a couple different combinations where one is even, one is odd, even, or both odd, odd. So there's a bit of a strategy just to using substitutions basically to try to get it positioned so you can do a normal substitution rule integration. So enough of me rambling on here about that. I'll take this problem right here and I'll solve it for you and I'll talk it through that way. Okay, so the problem was take the integral of sine to the 6th power x cosine let's see, to the 3rd power x dx. Okay, so from, let's see, middle school or high school, wherever it was, you started to learn sine squared plus cosine squared x equals 1. Okay, so looking at this, that means that I want to get into a position where I just have one cosine. Because this is an odd number here, I'm targeting it because I know that if I do cosine squared x equals 1 minus sine squared x, I can use substitution rule where if I set my u equal to sine x, my du will be equal to cosine x dx. So therefore my dx that I would be substituting in would be 1 over cosine x dx. And I can get rid of that last cosine just through this substitution here. And then just do a normal integration like for u. Okay, so showing you how that actually works, let's take this integral here. I'm going to leave the sine 6x there. And then I'm going to take the, let's say, cosine squared x times cosine x would actually be cosine to the 3rd power. So this first one here, I'm going to change that to this guy. 1 minus sine squared x. And then my other cosine will just have to be lingering here. X. So no problem, right? So now I have the one cosine that I need for this substitution rule. So I can directly go and substitute that in right now and even leave it in its own form and then deal with it. So I'd have u to the 6th there. I'd have 1 minus u squared, and then I'd have my cosine still in the x domain. Then I substitute in dx, which would be 1 over cosine x dx. Okay, so you can see that cancels with that, and then I'm just left with u to the 6th 1 minus u squared d. Oh, I'm sorry. That's not a du. That is a d. That's a du. It's not a dx. It's a du. Okay, forgive my little mistakes here and there. Hopefully it doesn't confuse you. Okay, so now I have everything in terms of u, and all my x's are gone. I can treat this like a normal integration that I learned many, many months ago. Okay, so integration 6u minus 8 du. And then I'm just going to take that and do my normal integration. Oops, not yet. Do my normal integration. So 1 over 7 u to the 7th minus 1 over 9 u to the 9th. And then I can substitute back in my u. My u's can be replaced by sine x. So I'm going to have 1 over 7 sine to the 7th x minus 1 over 9 sine to the 9th x plus constant c. Okay, so that is the first part of how to do one of these basic trigonometric integrals just by using a simple substitution there. So also keeping in mind, if you have a secant, x or combination or tangent, you can also use, let's see, the equation where tangent squared x equals secant squared x minus 1. And then the inverse of that would be secant squared x equals tangent squared x plus 1. So same type of rules apply. So typically the textbooks do swap in secant and tangent, or cosine and cosine, or sine and cosine, and use these basic ones. Okay, so I'll stop there on this one just to keep these videos somewhat short. And then next time we'll do kind of even combinations and see some variations there. All right, good luck. Hope this helps.